It's okay. Good evening. So I'm not sure how many of you can attend today. So suppose this class to have 37 students registered so far. So I'm not sure about the manual registration. So but since most of the slots are overlapping with other subjects, so I just choose the two the least overlapping subjects slots, okay, which will be on Thursday and also Friday. Okay, so for now what we will do, each week we will have 2 weeks of lecture for the subject because it's a true credit hour subject. So we will have a 1 hour face to face, so which will be on Thursday, okay, 4 to 5, and we will have one more hour on Friday, 11 to 12 online. Okay, is it okay for you all? Okay, so I hope. So just to introduce myself, okay, so since we are first time meeting, so I'm Dr. Allen, so I'll be teaching the subject. Okay, so I'll be teaching the subject for a few years, but not for diploma, not for degree. I was teaching for diploma, but the syllabus for degree is much easier than for diploma. So because I was teaching, then I was seeing, oh, only this. Okay, so it's a good news for you because the syllabus is already compressed, okay, to deliver only the introduction to thermofluid, okay, not the advanced thermofluid. Okay, and this subject is very important because you as a mechatronic engineer, you cannot escape from thermofluid. Okay, so I don't know how many of you already listened to the lecture video last week. So I only managed to upload yesterday. So if you haven't, so please go and listen back. So it's just like 1 hour. So all our class will be only 1 hour. So all the recording. So you suppose can able to listen. Okay, listen without any issues. Okay, so attendance is a bit tricky because some people cannot attend, so due to schedule. So what I will do for those who are attending face to face, okay, later I will give QR code. Okay, so you just need to fill in, and I will put the attendance spreadsheet in the Google Classroom, so you can monitor your own attendance. So if the percentage is not good, so you will be issued a warning letter. Okay, so it's the procedure, and if still it's not improving, then you will be barred from the final exam. Okay, so you all know for degree, if you fail your final exam, so you consider fail the whole subject, okay, which you need to repeat again. Okay, so that's the execution. And those who cannot attend the face-to-face class, okay, so I will upload the video. Okay, so I normally will give the YouTube link. YouTube link you can listen over and over again. Okay, so even if you attend the face-to-face class, so you can, if you don't understand certain things, you can listen again. Okay, and those who cannot attend the face-to-face class, I will upload the video in the Edpuzzle. Okay, Edpuzzle, I don't know, have you gone through any assignments in Edpuzzle before? No? So Edpuzzle you cannot skip. You cannot skip. So in between I will have questions. Okay, for those who cannot attend. Okay, so those who didn't attend today, so they need to go and listen back the Edpuzzle video and need to answer questions in between. Okay, and those who are attending face to face, I will ask question directly, and I will invite you to in front to explain certain terms. So make sure you pay attention. Okay, is it a deal? Okay, so I think 37 of you, easy for me to remember, and easy for me to call also. Okay, so any questions before we start? How many of you are ready for questions? Okay, so all of you are engineers. Okay, I consider, even though you are still studying second year, but all of you will be an engineer, or some, if you unfortunately, you will become lecturer like me. Okay, so you will come in front and you need to teach. Okay, so you need to prepare yourself. Okay, I'm in charge for the industrial training also for the faculty. Okay, so later part when you are doing industrial training third year, so you will be seeing me also. Okay, so you need to prepare yourself for your industrial training and for yourself to be an engineer in the industry. So one part of your preparation to industry, you must be able to present, you must be able to explain. Okay, so this subject, principles of thermofluid, so we will be studying the principle behind the thermofluid concept. So there are a lot of concepts involved, even today's class. So today's class is only 10 slides, including the front page. Okay, but there are a lot of things in between. So I can ask a lot of questions. Okay. Our second page also is included in the 10 slide. Okay, so chapter outline. So we will be looking maybe for today, it's only point 1 and point 2. Okay, so this subject is a bit relaxed because 30 plus 33 slide we will be covering 2 weeks for 4 parts. Okay, so we'll be studying little bit by little bit. So you must be, I am thinking, so you can focus and you can understand. Okay, so we'll start with 2.1. Okay, systems and control volume. Okay, firstly, we want to understand what is thermodynamic system. Okay, so we have heard about this term. What is thermodynamics? Okay, so thermo, maybe you have a concept, understanding. So thermo is related to temperature. Okay, dynamics meaning movement. Okay, is it really on that? Okay, so you can see thermodynamic system. So it's a system. System meaning is a combination of few things. Okay, so what is thermodynamic system? A quantity of matter or region in space chosen for a study. Okay, so if you want to study something related to temperature and also dynamics, so you must have a system where you will be focusing and studying. So you cannot, you cannot study the whole system. You cannot study the whole thing in the industry or in the production line. So you will be choosing a particular region for you to conduct study. So that is what we call as a system, and in the subject thermodynamic system. So if you can see, so this is a system. So you only focusing on studying this part. Okay, so this is the first thing. Second, surrounding. Okay, the mass or the region outside the system. So you have a system and you have a boundary, the blue color. Okay, and apart from that you have a surrounding. Okay, you have a surrounding. So this is what we call as a surrounding. So the explanation, the mass or the region outside the system. So you have a system is outside the system. So whatever around the system. So in today's lecture we will study certain terms. Okay, related. Okay, then we have boundary. So boundary is the real or imaginary surface that separates the system from its surrounding. Okay, so you can see based on the color. Okay, the red, orange or red. Okay, so here it look like a red. Okay, so since it's a orange here, so it's an orange color. So orange color is representing the system, and the blue color is the boundary. So the boundary can be something that can be seen. So we call it as a real, something that is physically available. Okay, and imaginary, so meaning is something that is not there but you imagine, that is a presented there. So it's a surface that separate the system. So you have a system here and you have a surrounding. So this boundary is actually separating. It is separating the system from the surrounding. Okay, so we have seen the basic of it. Then we will look at two types of system. Okay, one we call as a closed system, and one more is an open system. So opposite to closed is open. Okay, so we will see what is closed system. So you will be hearing this term always in mechatronics: closed system, open system. So what is actually closed system? So closed system has another name called control mesh. So control mesh. So if you see here, so this is a closed system. Okay, so it's fully closed, and inside this container, so you have a mesh. So it can be a thermofluid, it can be a liquid, it can be a gas. So it's inside this container. Okay, so for closed system, the definition: a system that consists of a fixed amount of mass. Okay, meaning the mass is constant inside. So let's say it's 1 kilogram. So the mass is not changing. Okay, it will be constant. Okay, fixed mass, and no mass can cross the boundary. So meaning, so no pathway for the mass to go in and out of the system. Okay, so if 1 kilogram will be inside. It's not moving in and out. Okay, so no mass transfer, but energy can transfer. Okay, so let's say you heat up this gas, so the energy inside will be moving and in and out because it can go past the boundary, but the mass is not changing. Okay, mass is not changing. Okay, that is the closed system. Okay, then we have an isolated system. Okay, isolated system is a special system that of closed system. So isolated system is actually a closed system because the mass is constant. Mass is not changing. It's a closed system. But in the isolated system, so energy is not allowed to change. So earlier the energy can change. It can go in and out of the system to the surrounding. But in the isolated system, energy also is not moving. So mass is already not moving in and out, so it's fixed. And in isolated system, even the energy is not changing, is not moving. Okay, so far okay? So you can understand? Okay, then we come to the open system. Okay, open system, the another name is control volume. Okay, so the volume is controlled. Okay, so you have a open system here. Okay, open system, normally you will have a inlet and outlet. Okay, so for the mass, so here the mass is not constant, so mass can go in and out. Okay, mass transfer is happening, energy transfer also is happening. So when mass is going in and out of the system, the energy can also transfer. Okay, but here the volume is constant. Okay, so even though it's expanding or shrinking, so the volume will be constant. So but mass is not constant. Okay, so the definition: open system or the control volume is a system that both mass and energy can cross the boundary of a control volume. Okay, so open system, mass and energy can transfer. Closed system, mass is not changing but energy is transferring. Okay, so far okay? Okay, so you have another 40 minutes. Okay, so boundaries. Okay, so boundaries, so I think you already understood the concept earlier, boundaries. But the boundaries, we have a few types. One is the fixed boundary and one more is the moving boundary. So if you can see, so you have a piston, okay, or a container. So you have 2 kilogram of gas inside and you are heating this container. Okay, so if you can see here, so you have a piston moving up and down So if you can see the dotted line, so that is the boundary. So at this side, so it will be fixed because it cannot go down, it cannot, but the other side, the other boundaries, it can expand, okay, depending on the energy transferring from the heat to the system. So after some time it will become like this, so it will be elongated. So this line is elongated, so this one is moving, so this one also is elongated, so this one is fixed. Okay, so this is a fixed boundary and this is the moving boundary. Okay, so that's the first thing. Second, for the open system, okay, so you have a fixed boundary and also moving boundary here, and there are two other boundaries available. Okay, one is the real boundaries, so you can see here, so you have a nozzle. Okay, imaginary boundary is something that is not connected to the surface. Okay, so here you have a nozzle, so this, you can see the black line, so that is a surface of the nozzle, and the real boundary is connected to the surface, but this side you don't have a surface, this side also you don't have a surface. So this is considered a imaginary boundary, and this is the real boundary. Okay, so far so good, can focus, can understand. Okay, so the thermodynamic relations that are applicable to closed and open system are different. Okay, therefore it is extremely important to recognize the type of system before analyzing it. Okay, so thermodynamics are involving a lot of calculation. Okay. Okay, so thermodynamics is involving a lot of calculation. So before you do an analysis, okay, so before you do a calculation, so you need to determine whether it is an open system, closed system, what is one more? Isolated system. So you have three systems. Isolated normally will not be in the picture, it's a special case. So normally it will be open system or closed system. So only that two. Okay, so before you do an analysis, okay, before you do an analysis, it is extremely important to recognize the type of system. Okay, before start your analysis. Okay, because if it's a closed system and you do a calculation for open system, you will get wrong value. Okay, similar in your exam. So later when you do exam, so make sure you analyze first whether it's an open system or closed system. Okay, so then we will study one more, properties of a system. Okay, what is property? Okay, when you have a system, so you need to have certain values for you to do calculation. Okay, so without this value, like earlier we saw mass, so we know we saw velocity or volume, so all these are a value for you to use in your calculation. So that is simply say what is property. So property in a system is any characteristic of a system. Example, pressure, so value of pressure, value of temperature, value of volume, value of mass, value of viscosity, so thermal conductivity. So all these are example of terms used in thermodynamics. Okay, so all these values are important because it's carrying a characteristic or a property. Okay, so which you will be using in your calculation. Okay, so properties can be divided into two. So first one is intensive. The second one is extensive. So there are two types. Okay, so what is intensive? So intensive is independent of mass of a system, because earlier we saw a system is having a mass. Okay, so intensive property is something that is not related to mass. Okay, independent of mass means is not related. Okay, so like temperature, so temperature is not related to mass. Okay, and pressure is not related to mass. Okay, it's two different things, and density is not really related to mass. Okay, so all these are falling under the intensive properties category. Okay, then you have extensive properties. Okay, depend on the size or extent of the system. So you can have a total mass. Okay, total mass in a system. Then you can have total volume. So volume is related to mass. Okay, mass is related to mass, right? And momentum is also related to mass. So all these are examples. So what if the property is related to mass? So you put it under the extensive properties category. So if not related, you put under intensive. Okay. Okay, so consider, so we see an example. So considering properties in a system as follows. So let's say you have a system. Okay, so the orange color, or is it a pink? So I also don't know. So but this color, so is a system. So what is the blue color? Boundary. So this is considered a system. Okay. So what is the white color? Surrounding. Okay, good. So already can answer the question. Okay. So in the system you have what is M? So mass. So what is V? Volume. So what is T? Temperature. So what is P? So what is this? Oh, okay. So good. Okay. So you have a system with all these properties. Okay. So you can equally divide the system into two. Okay, so let's say you have some values for this. So you can say, so T is not related to mass, P is not related to mass, and density is not related to mass. So all these are falling under intensive properties category because it's not related to mass. And you have a mass here, 0.5 and 0.5 volume. So these two are falling under extensive properties. Okay, and apart from that, so we have certain specific properties. Okay, we call it as specific properties. So for example, specific volume, specific total energy. So when the term in thermodynamics is related to specific, let's say in the question is mentioning specific. So whatever value that you are having, so you need to divide by M, divide by mass. Okay, so specific volume, so small v equals to bigger V, so the total volume divided by mass. Okay, so that is what we call as a specific volume. Okay, so specific properties, extensive properties per unit mass. Okay, so in thermodynamics, so if you have the term specific is related to per unit mass. Okay, so specific total energy, so smaller E equals to bigger E divided by M. Okay, so far okay, can understand? Okay, so 2.3, density and specific gravity. Okay, so density and specific gravity. So density, the definition is mass per unit volume. Okay, so this is the formula. So density, so rho equals to M mass over volume. Okay, and the unit is kilogram per meter cube. Okay, so M is mass in kilogram, so V is volume in meter cube. Okay, so the density, so this is the definition for density. So the density of a substance in general depends on temperature and pressure. Okay, so it's related to temperature and pressure. The density of most gases is proportional to pressure. So meaning if the pressure is increasing in a system for gas, so the density also will increase, okay, and inversely proportional to temperature. So meaning if the temperature is getting lower, your density will become higher. Okay, this for gas. Okay, and for liquid and solid, the variation of their densities with pressure is usually negligible. Okay, in liquid and also solid, so pressure is not doing anything inside. Okay, it's not really affecting the density of the liquid and solid, but for gas it's important. Okay, so similarly, if you want to do an analysis, you need to know whether it's an open system or closed system. Then you need to check what it is inside. So whether it is having a liquid, whether it's having a solid, or is it having a gas. So based on that, so you can determine what you want to do. So what method you want to use to solve. Okay, so we have a specific volume. So earlier I say if the term specific is used, it is per unit mass. So specific volume, so volume per unit mass. Okay, so specific volume, the calculation is, so smaller v equals to bigger V divided by m. So because it's per unit mass, so if you see here, so density is m over V. So here V over m, so it's opposite. So 1 over density. Okay, 1 over density. So the unit is meter cube per kg. Okay. So all these things you know. Okay. Then a term called specific gravity. So specific gravity is the ratio of the density of a substance to the density of some standard substance at the specific temperature. Usually water at 4 degrees Celsius, for which rho H2O water equals to 1000 kilogram per meter cube. Okay, so this is another term that can be used in thermodynamics for your calculation. We call it as a specific gravity. So it's a ratio of the substance. So let's say the substance is a wood. Okay, so the substance divided by the density of water. So this is the calculation. So specific gravity, or SG, okay, not Singapore, okay, SG equals to rho. So rho of the material that you are investigating. Okay, so it can be, so let's say gold. Okay, so rho density of the gold divided by density of water. So you will get the specific gravity. Okay, so normally you will have a table. Okay, so this is the table. So you can see, so water, so y is 1, y is the value is 1. So try to think, y is 1.0. So the specific gravity of water, why is complete silent? Kenapa satu? Why 1? So you see the formula. So if you want to check the substance, so it's the density of the substance. So what is the substance here? If water, so rho H2O divided by rho H2O, so you get 1. Faham? Okay, understand? Okay, so blood, so 1.05. Okay, so density of blood divided by density of water, so 1.05. So if 1.05, so which density is higher, blood or water? Blood. So blood is always thicker than water. Okay, so the density is higher. So similarly you can check, so sea water 1.025. So sea water, we know that the density is higher. Gasoline, okay, your petrol 0.7. So water is the density of water is higher. So then you have ethyl alcohol, you have mercury. So mercury 13.6. Okay, so the density is 13.6 times higher than water. Okay, then you have wood, Okay, wood is relatively lower. So always imagine, okay, let's say you put wood on the water, is it floating or not? Okay, so wood will float, so meaning the density is lower, that's why it's floating. Okay, but if you put blood in the water, it will sink. So don't know, I never tried before, you can try. Okay, so similar gasoline, so you put a petrol on the water, it will float because the density is lower. So you can check. So if you put this, you call me. Okay, because I want to come and take. Okay, 19.2 gold. Okay, so gold. Okay, this one you can try. Bones. Okay, ice cube. Why is floating? Because the density of ice cube is lower, so it's floating. Okay, air is very light. Okay, so you understand specific gravity. Okay, and one more term, specific weight. Okay, weight of the unit volume of the substance. Okay, so specific weight, so you have a symbol gamma equals to rho g. Okay, density, rho is density of the substance times with gravity. So you can get specific weight. Okay. Okay, so any question? So that's all for today. 10 slides, right? I said we study little bit by little bit. The main thing is you understand. Okay. Okay, ready for question? Okay, so before I ask question, do you have any question? Yeah? Any question? No? Okay, so if no, you can stop the recording.